Alright, so here's the continuation of day 2, the stuff that you couldn't do or didn't have time to do. You could have done it, it just would have taken too much time. Ain't got time for that. So here's the deal. You left it like this. You should have some kind of either bluish or clear solution with the copper and possibly some excess aluminum in there. We don't like the excess aluminum. So what I'm personally doing, first of all, is well, it's called decanting this solution. So over here is my big waste beaker. As you can see, I've got some copper in there. Maybe a lot of you lost a tiny bit of copper. So to decant basically means to pour off the liquid while keeping the solid in the original beaker. So I'm just going to show you basically what's going on here. So I'm pouring off. I'm being extremely careful. I don't want to put on video that someone's losing copper. Alright, so whoever this is not losing any copper. Woo! Perfect. Alright. Alright, so here's what we're left with afterwards. So all the excess liquid is gone. But unfortunately there is aluminum in there. So that's where the acid part comes into play. Now we had to add excess aluminum because we had to make sure all the color went away. So I'm adding some, over here, some 6 molar hydrochloric acid. Alright, so 6 molar hydrochloric acid, and what you see happening is a little bit of bubbly. And the good thing is that the copper is not dissolving, the aluminum is. So that's an awesome thing, or awesome reactivity point about hydrochloric acid and copper. They will not react, but aluminum and copper will. So, hint, conclusion, that's a pretty good indication of why we need to add the aluminum. Alright, or sorry, not why we have to add aluminum, why we have to add the acid. Alright, so fast forward, power of video, that's going to sit over here and just kind of sit there for a while. After a while, I get a solution that has no aluminum left. Alright, so there's no aluminum left in there. All I'm going to do is, now it's still a little bit acidified, so this waste beaker will be neutralized and taken care of accordingly. So I'm going to again decant that solution, and we're just left with some copper. Awesome. But that copper has a little particulates of some acid still on there, maybe some aluminum. So I'm going to use some distilled water and just kind of squirt it in there to clean, to quote-unquote clean the copper. And eventually what's going to happen is we're going to have cleaned copper, which is using another beaker perhaps. So yes, I've done this. I think this should be pretty good. Alright, so that's going to be decanted, and all of a sudden, oops, we're left with some decent copper on the bottom. But unfortunately the copper is wet. So I'm going to put it over here with a bunch of the other ones. This stuff is nail polish remover. It is used to quickly dry things. If you put nail polish remover on your hands and then it evaporates, your hands are extremely cold and extremely dry. So what I'm going to do is pour some of this into the beaker. Should be fine. Alright, now this has some acetone in it. I'm going to let it sit for a little while. Basically what's happening is it's drying the copper out. So when I pour it out into this little waste beaker here, the copper will be saturated with acetone. Overnight I'm going to let it sit and it's going to dry out perfectly. And then we can scrape off the totally dry copper and you can mass it out and your experiment's done. So all these are done. I still have this many to go. Alright, bye.